All right, thank you everyone for coming. We're going to be covering a lot in this panel, and I don't know if I'm going to move too fast because I don't know how much I have to cover, or if I'm going to move too slow and not get enough time for you guys to ask questions. I'm going to do my best to go at the proper speed here. We'll get plenty of time for Q&A because I don't know if I'll cover the breadth of questions you may have in here. So what are we going to be covering in here? This is elevated armored cosplay, and so this is where normal PLA, normal foam isn't doing it for you, and we want to take all of that to the next level. It's advanced 3D printing materials, rigging and attachments. Again, the breadth of this panel is pretty wide. I've got a couple other panels where we're going to narrow this down a bit, but this is the wide scope. Comfort and fitting, raising the tech bar. Is this real or is this cosplay? And I say, is it too much to ask for both? Which is what I go for when I'm doing my cosplay. We'll talk a little bit about that. This is actually not a vanity play. I'm just curious, who knows me at all? Who has seen my YouTube channel? Just because it saves me a little bit of time. All right, there we go. I appreciate that. So we're going to go through that here. Who am I first? Why should you care at all that I have anything to say on the subject? Let's see if it's going to work. There it is. All right, so I have been cosplaying in various forms for probably the better part of 15 years now. I sew, I 3D print, I didn't make all of this, but I made parts of a lot of this. I have kids and they have all cosplayed, and so I have sewed a many of cloaks and capes, and I have worked with Iron Men, and that is what I'm still working on today. All right, so obviously a lot of 3D printing goes on in my garage. I've got a number of different machines for these large props and cosplay items. This is where I kind of started. That's this helmet over here being printed in regular PLA or PLA Plus at the very best. And this is the new helmet, which you're looking at right here, which is not my final one. My final one I left at home, but this is a sample that I printed. And this is the latest stuff I'm printing in. This is nylon carbon fiber. So it is PA6 nylon reinforced with carbon fiber flakes or shreds, whatever you want to call it. All right, I also do 3D modeling. I'm particularly good at modeling mechanical designs, not particularly good at modeling things that require a lot of creativity and artsy stuff. So if I release models, they're in the shape of things like this, not in the shape of things like this. I typically buy these from other people that are much more talented with this kind of shapes. And I've been working on my YouTube channel, which is Frizzy Fabrications. I've got about 42,000 subscribers at this point, and I've started a second channel, which I'll show you at the end, called the OASIS Project, which is going to be surrounding my software that I'm releasing for all of this kind of stuff. And I have been working for the past almost 4 years now on this project, which I'm not doing the audio on here, but this is the Iron Man helmet. I do have it up here. I didn't have time to set it up and go through everything. I was going to do a live demo, but it's got a heads-up display in it. This is what it looks like when you're in the helmet. So this is all real-time data. All of the data is actually real, streaming from various instrumentation that is in the top of the helmet. And I'm going to cut through here. Got to have the cool logo if you're going to make cool things. Luckily, I have some artist friends that can do that. This is how I start when I'm doing a project. I'll 3D print this little mounting board and get the parts that I need. So this is a NVIDIA Jetson. So if you're building anything like this, you need a high-end computer. We're going to touch on that towards the end. And running on crud, but that's okay. The heads-up display runs better than my laptop, so that shows you where the money goes. Yeah. The laptop hasn't been upgraded in 6 years. I've been through 4 versions of the Jetson. Anyway, so it's got these mini RGCam IMX 477s that you can see in the eye sockets here. And we'll go through this a little bit later. I want to make sure I have time for everything. But anyway, you've seen a bit of that, and we'll talk more about the details of the OASIS project later. All right, let's go through 3D printing materials first. You're in here for advanced materials, and so let's talk about that. I've bought a lot of sample pieces One thing I didn't say at the very bottom, this presentation is more of a show and tell. I want you to actually be able to touch things if you want to see things in person, and to see the differences on why we care that we're not printing everything out of PLA and why we're not just building everything out of, closed cell phone. All right, so let's go through some of the 3D printing materials. I'm going to give you a quick primer through these and basically tell you why you might not want to use some of them and why you might want to use others. So PLA is the standard 3D printed plastic that if you have a 3D printer, that's where you start with. It's easy to print with. It doesn't warp. It doesn't change sizes a whole lot. But that doesn't mean it's the best 3D printing material. Obviously, it has, given the fact that it's easy to print with, it means it has a relatively low melting temperature. And so if you leave it in your car, you'll find out that your prop isn't in the same shape that it was when you left it there. It's not a very good thing. If you've ever left a helmet, I even tried to build a couple of mechanical parts out of it. You leave it in a car, not even on a hot day, and it will warp and distort. Particularly if you haven't painted the part or anything like that. So PLA, not the best thing. It can warp if you're wearing it in the sun too long. And it's relatively brittle compared to some of these other materials that we have available to us. So if it's the number of armors that I have seen broken because someone bumped into someone or because they packed it wrong and it doesn't make it to their destination, you will notice a number of cosplayers that are online will have horror stories of I flew it across country, when I got it there, my chest piece was broken in half. So that may be why you don't want to print everything out of PLA. PETG is the next step. It is what you will also, most printers can print it without having to be modified at all. PETG is it's a good material. It has a higher melting point, so it may not melt in your car as well. If you're going for like a transparent material, it's nice. There's a lot of transparent PETGs. The PETG stands for, it's basically your plastic water bottles that are glycol modified, which means they're easier. So, like I said, this is a PETG, and you'll notice though, these have a very thin piece. It's got a tang that goes into the hilt here, and this broke on the way here. So, again, these are test pieces. I wasn't concerned, but it does demonstrate why you don't print with some of this material. All right, so we move on to ABS. ABS is probably what most of the plastic items you own is made out of, and it's a very common plastic. It's very inexpensive, but if you're printing with it at home, it has off-gassing problems. You're not going to print with it in an area of your home that a lot of people are living in, or that doesn't have very good ventilation. I've heard that ABS and ASA is an easier to print with and more stable version of ABS. I much prefer printing with it than ABS. But anyway, the material is better to print with. It has a higher printing temperature. It probably will not print on most off-the-shelf like Reality 3D printers. You may have to modify your hot end to be able to handle the higher temperatures if you're printing with that. But like I said, it's a very durable plastic. It's much better than a lot of the plastics, the PLAs and the PETGs in terms of durability. And it does sand pretty well, and if you've ever heard of something called vapor smoothing, you can vapor smooth with it, which is nice because it can get rid of layer lines. Disclaimer, vapor smoothing can be dangerous if you don't know that it can explode if you're not careful with it. No open flames near vapor smoothing. All right, so we move on to some of the more advanced stuff, and you'll notice here there are way more plastics available today than I have up here. These are just the most common. I didn't even cover some of the things that are more exotic than this because you get into pricey stuff or you get into stuff that it's just very difficult to print with. Anyway, so I have to say my new favorite material is the PA6CF, otherwise known as carbon fiber reinforced nylon. That is what you will find this piece printed out of, and it's what you'll find this piece printed out of. And with these pieces, I'm finding, I am going to throw a plug here for Polymaker. They have sponsored this particular build, but I actually chose them and bought it myself before I chose the sponsor for this build because I wanted something that would print in an open machine. A lot of these materials such as ABS, normally nylon, polycarbonate, they require an enclosure to print with properly. Otherwise, you have warping. It will warp off the bed, and you will never get a good part out of it because as it cools, it warps. And so you have to have a heated chamber in order for them to print properly. I find that particularly Polymaker's PA6CF does not warp on the bed. I'm printing with open printers throughout my garage. My garage is warm, but not that warm. And this is not warping, this is printing really, really well. The only key to nylon is hygroscopic, means it absorbs every bit of moisture in the air, and it will, if you do not keep it dry the entire time you're printing, not just at the beginning of your print, but the entire time, it will start bubbling up on you and it will ruin your surface. This piece here, you'll notice there's a little stringing on the inside of it if you come up or if you can see it from there. That is due to it absorbing some moisture during the printing process. I had pre-dried it, it started really well, but then as it printed, the dry box I'm using is not 100% dry, and it did absorb some. It doesn't ruin the print, I can still sand this down, but it's important to note that it is really difficult. I now own 2 toasters in my garage that's for drying nylon carbon fiber, and then if during a print I notice that I'm hearing something from the nozzle where it's bubbling, where it's making kind of it does sound like bubbling. It sounds like it's dehydrating as it's printing. And then I will have to stop the print there, dry the filament for 12 hours, and then start over. Not start the whole print over, but just start the process there. But that is a common part of this process. Polycarbonate, very difficult to print with. It's a lot like ABS. It will warp up on you. It will, it's very sturdy also. If you're familiar with polycarbonate, bulletproof glass, things like that, if it's thick enough. But it's impact resistant. It's not particularly bend resistant. It doesn't give like the nylon. So the great thing about the nylon, it flexes, it bends. If I really tried hard, I could bend this piece, but I can hit this with a hammer and it's not breaking. I've tried. I was going to do it here, but there was a blast radius problem, and I didn't really want to take out the front row with showing you doing a demonstration of this. But there will be one on my Instagram account very soon. So I'm going to demonstrate that you can take a hammer to this stuff, and it really does hold up. You have to bend it pretty far in order to get it to break. Unlike polycarbonate, if you got a relatively thin piece of polycarbonate print, it will crack on you pretty easily. But it will take an impact if you have a particular case for that, if you were printing something like a visor or something. But anyway, that's that. And then TPU, I've got some example of thermoplastics up here. These are fantastic if you need something flexible, like a seal or maybe part of your leg. They're not infinitely flexible. This TPE that I'm running right here, this TPE is the best stuff I've used. And you can see this is they come in shore hardnesses, so that's what they're measured in. This is about an 80 or an 85 if I'm not mistaken, but you go up to like 95. This is flexible, but I wouldn't want to wear it. So pay attention to shore hardness. Again, the TPE I've got here is about the best stuff I have. I'm drawing a blank at the moment with the amount of things in my head as to who makes this one, but there was only like one company making a TPE. So if you look that up on Amazon, you'll find it there. All right, that's 3D printing materials. I don't mind if we do a quick question, if anyone's got questions at this point. Yes?
When you say heating, mean which one you have to dry?
The nylon? Yeah.
Do you mean like, if it accumulates water from humidity on it?
Mm-hmm.
Okay.
So it absorbs the water from the atmosphere, and you can dry it. So if you've left it in your garage and it's fully absorbed all it can, you can still re-dry it, but you can't print with it at that point. Yeah.
The TP6, sorry.
Yeah.
What machine do you need to print with that? Can you use just anything to print ABS?
The PA6, the nylon? Yeah, so nylon, the one I'm printing with, you need to be able to hit about 290 Celsius on your printer. So it would be considered a high temp filament, but not an exotic. So most off-the-shelf printers, even from Creality, the ones from Bamboo Labs, most of those I think are high temp or have a high temp option. You just need to make sure that you do not have a piece of It's a plastic little tube that goes in the middle of, you have to have an all metal hot end, let's put it that way. If you have an all metal hot end, you can usually print up to 300 degrees Celsius. Okay, so and 300 is basically, most printers can go up to 300 due to the thermocouple that's in there. They have a thermistor, and that thermistor tops out at about 300, which is why most printers can't go over that 300, even with an all metal hot end. Because I've got a hot end that can go higher, but I have to replace my thermistor with something that can go higher. Yeah.
What do you prefer for beds? You prefer glass or do PEI, I'm saying that right?
Yeah.
And do you use hairspray? And what brand?
Okay, so I do not use hairspray, mainly because I don't like the mess that hairspray leaves everywhere.
Yeah.
So that's why I never did it. I did buy some Aquanet because that's what they were recommending, and you can still buy Aquanet.
Do you have to go search for it? Because it's hard to find.
Yeah, I think I was buying it online, but no, I am using the flexible PEI plates on all of my machines at this point. I was a big glass fan for a long time. For printing with glass, glass is still a fantastic option, but you do need something on it most of the time. So I'm putting, what is the stuff I've got? The nanopolymer adhesive. It's not cheap. The larger bottles of it are about $50, but it'll last you a long, long time because you don't have to reapply it between every print. You don't reapply it until you notice it's not working anymore. But the nanopolymer adhesive, you can find it online, you can find it on their website. Vision Miner is the one who makes that nanopolymer adhesive. It's the best stuff I've used. And worth every penny not to have failed prints.
How realistic would you say like thermistor, changing out the thermistor is, and then once you do that, do you have any issues with like voltage regulation or anything like that?
So the biggest thing about the thermistor change out is it requires a change to your firmware. So as long as you're willing to change your firmware, recompile Marlin, or reconfigure Clipper if that's what you're running, as long as you're willing to redo your software, not a big deal. You can find the parts online, replace it. Usually you can find something that'll fit your printer, but just know that you have to make a software change. And for some people, I'm not going to mess with it. All right, let's go on, and we'll have some time at the end. All right, rigging and attachments. So I'll be absolutely honest with this one. I'm in the middle of building my first complete Iron Man suit. But that means that I have thought about this for 3 years and have researched the heck out of this for 3 years and know basically what I'm doing with my suit. But I want to be forthcoming that I haven't finished it yet, so here's where we are. So we're going to go through all the different ways you can attach the pieces of your armor together, whether you're building an Iron Man suit, whether you're building a Halo suit, whatever you're building. Glue. Glue is my absolute last resort. I don't like glue. I try not to use glue unless I'm like, okay, I guess this will come off later if it needs to, or I'll reprint it later if I have to, because once you've glued something down, particularly the type of glue you've used, it's not coming apart, at least you hope, right? That was the point of using glue. But given the fact it's not a mechanical attachment, it cannot be redone, you cannot pull it apart later, and so glue is, to me, a last resort. I couldn't figure out any other way to attach this. Now there are some glues you can use, some hot glues, some of the stuff, I'm drawing a blank on the name of the glue, but some of them will come off if you want them to. You pull enough force and they won't break, and the glue will break before the part does. But just keep that in mind, that's kind of last resort. Velcro, I love Velcro, but Velcro, particularly if it's something that's going to move around a lot, isn't necessarily your best friend because Velcro makes noise. It gives a little, it starts to break a little, and then by the time you're done with the walk around, you realize it's falling off of you. Pay attention to the type of Velcro, the type of attachment the Velcro has, whether you're sewing it on, whether you're gluing it on, whether it has a sticky back. There's industrial Velcro, there's the Velcro that you can get, at your local fabric place that's designed for clothing. There's a whole lot of different materials in the Velcro line, so pay attention to how you want to attach it. And again, the use case and the temperature range and all that kind of stuff with the adhesives that you may find on the Velcros that you can find. So screws and mechanical attachments, that's my favorite. If I can find a way to screw something together, that's the way I want to go because I can refigure it later. I can take it apart to work on it. So everything in the top of this Iron Man helmet is assembled with screws. Nothing is glued together. It's either screws or magnets. So there's been multiple times I've needed to pull this helmet apart, that I've needed to rework the electronics, that I've needed to do something to the faceplate because I had to replace one of the LCDs in the heads-up display. If it was not screws, if I glued it together or any other types of permanent attachments, I could not have worked on this, or I would have had to tear it up to work on it. And so when you're doing that with 3D prints, I can show you that on this piece over here. This is a test print for my chest plate on my new suit. And this armor designed by Do 3D has built-in screw attachments. They designed it this way. It's not throughout the suit, but is in some of the more permanently attached pieces. Now, they did it probably because this makes this suit much more travelable. This thing would break down into quite a few pieces if I needed to travel with it to keep it from breaking. But what you'll do is when you want to do attachments like this, in my helmet there, you do these little melt-in inserts that will melt into almost any thermoplastic that you've got, and they melt in, and then you put the screws in them, and now I have a mechanical attachment that will not wear out. And again, these are just threaded inserts. You can find them on Amazon. They come in all different shapes and sizes. There's a new one I have. I'll be talking about it in a video because I don't have the brand off the top of my head. Again, it is available on Amazon. That instead of a melt-in insert, you can drill a hole, and it is a press-fit insert. It's a lot easier to do, but they have less options because I think it's a patented, because I've only seen it from one company. But it's a press and insert, and then when you screw it in, it tightens the hole up. And I like those a lot better because these melted ones are kind of a pain sometimes. And you guys can come up and see this after the panel, though I think there's about 15 minutes between panels where you guys can come see this. All right. Different plastic buckles, rings, etc. You guys are probably, if you've lived any amount of time, you have a backpack that has a plastic buckle on it. These are fantastic when you need to do rigging, when you need to make straps of any kind. Those are really nice. But let's be honest, we're talking about some more advanced techniques. I'm going to put down the microphone here because I need 2 hands. And these are my new best friends. I love these. These are tactical buckles. So you pull on these and they just pull apart, and they're metal. We're talking about higher end materials, and then they just snap back together. They're quick release. Again, they're called tactical belt buckles, tactical buckles. You can find them on, again, I bought these on Amazon. In fact, the best value one I found came in this nice multi-pack, which has a whole bunch of different sizes, and they just take the place of the same plastic ones that you've always been doing. But I really like these because a lot of the times, in a lot of your armors, you're going to have things that show. And if they're going to show, let's make it look like it's part of the costume. Let's build it like it would have been built if it was an actual suit of armor. And you're not going to have plastic belt buckles on your $2 million armor. Right? So that's why things like this are really nice. Look for things like this. They're more expensive than that. But this will not break your budget for, your whole armor. I think this whole pack was, under 20 bucks probably. I don't remember, but something like that. It was pretty cheap for the number of buckles like that. All right, and then of course you've got 2 different types of webbing when you're doing these straps, and I wanted to mention that. So you have the polypropylene webbing, which is the one that you have on here. It's kind of fabric-y feeling. It's a little bit more bendable and flexible. And then you have nylon webbing. Get a sample of each if you can. Go to, like I say, go to Joann's. They're going to have both nylon and polypropylene. And they have different uses. Find out which works best for you. I like the polypropylene in a lot of situations, but I find the nylon is thinner. It's smoother. And in a lot of places, I think it might fit better than something like this, which is thicker. But pay attention to what's also going to fit your buckles. And then let's talk about the last one here, direct fabric connections. Putting things together by gluing fabric on the back of them. That's one of the things I'm going to be doing in my armor. It's one of the things I'm most scared about because it's glue. But I know that by gluing it, I'm going to build one cohesive piece of material as opposed to what I said earlier, if I were to use Velcro, then this really turns into a big problem because now they're going to be making noise the whole time and an armor plate might pop off. So using some sort of adhesive, in this case, makes a lot of sense. And so we've got different kinds of materials. I've been looking at flexible fabrics, the spandexy type stuff. You usually find it if you go to Joann's or a fabric store, you'll find it in the performance fabric section. It has usually some amount of give, flex to it. Some of them are cotton, all kinds of different materials. And then, let's see, do I have that in the next one? Yeah. In the next slide. All right, so the next slide, this is connected to it, which is when you're backing something, it can be a connection between materials, and it can also add comfort and flexibility. Okay, so if I'm building something like this, or something like this, right, that are going to be armor pieces. These don't flex, these don't move, but if I can put connections between them that do move, for example, the stomach piece for this has like 3 different pieces, right? And then that connects to another piece, and that connects to another piece. Well, if I were to back that, now I have something that is a hard piece of armor, but it also still flexes, it also still gives. It gives me a little ability to stomach crunch. Think about it, if any of you own Hot Toys figures. I've actually been using Hot Toys figures to figure some of this out. So you buy a Hot Toys figure, you find out like they've made that figure posable. They've tried to make something made of hard plastic move, right, like a human being. And so if you take that figure, you find out where does it need to be cut? Where do I need to put connections? Because this is hard, but yet it still does all these poses. And I'm using that kind of to inform me, where do I need to make myself posable? Right? Because I don't want to not be able to reach the floor. I don't want to be able to not reach my chest. This comes from a lot of experience of, again, doing a lot of research ahead of time, seeing the problems that other costumers have had in the past. Right? I've got a lot of friends who do this that have already made their full suits of armor that can barely touch their nose. If they drop their room key, they're out of luck. You know, that kind of thing. And if I can get around some of those with my first build, then I have accomplished something mighty. So, again, there are different kinds of foam and other things you can use for padding. There is the standard closed cell foam that most of you are familiar with. This is the PVA foam almost everyone builds armors out of, and you build all sorts of costuming out of. These are floor mats that most people use, and you buy these all sorts of places. It's very inexpensive, but it's not very comfortable. It's light, but it has kind of a plasticky, rubbery surface. You need to do something with it if you're going to make that feel nicer. Then you have things like this, which are this is the open cell foam. This is like the stuff you'll use in cushions and pillows and things like that. Very comfortable, but not supportive, right? It's very thin, it's very flexible. I use this along with this, which is a quilt batting. Again, you can buy this stuff at all your fabric stores and everything. And I used this and this to do the padding in my Iron Man helmet. So it actually has the harder stuff it has on the top of the helmet, because it has more padding, and then I use the batting on the sides of the helmet to protect my ears. And again, this is for support. This protects the electronics that are in the top of the helmet, while this just gives me some comfort in the sides. So again, don't be afraid to buy multiple materials, test them out. Again, the number of mistakes, or I don't call them mistakes, they're just test runs of things that I do at home, because I want my final version that I spend lots of time on, particularly painting and finishing and everything. That's where I spend way more time than the printing and the testing. So when I get to the point where I'm ready to paint it, then I definitely want to be comfortable with what I'm painting, because that's going to take all my effort and time. Okay, and then last but not least, this is my favorite new stuff. So when I was doing all of my research, when I was trying to figure out what I want to line my armor with, I took inspiration from 2 things. Number one, what do people wear that is both flexible, water resistant, temperature resistant, and then I also looked at the movies, and you look at what are people wearing that have to wear this stuff. What did the artists and the prop makers and everything end up with for a lot of the props, and I end up with neoprene. Neoprene is a space-age material. It was invented by NASA originally, and it is a fantastic material. This is the same stuff wetsuits are made out of. A lot of wet shoes are made out of this stuff. And it is really nice because it is both padding and fabric. It is glueable, and when you cut it, it doesn't fray. So you don't have to finish your edges unless you're going to see them and want to do something with them. But you'll have to finish them for the sake of the material is going to keep tearing up otherwise. So I'm going to be lining my whole armor with neoprene. And again, the fact that it's wetsuit material means it's going to hold up to you sweating on it. And, you know, it won't absorb all of that. You know, spreads it off a little Febreze, and it should be ready to go for the next armor outing, or at least that's the theory. And then one comment I wanted to make here on the sewing and the gluing. Getting some basic sewing skills is very valuable, and you don't have to be the best at it. No one's going to flip your seams, but you know when you can sew on your Velcro, when you can sew together your strapping, you'll notice on some of this strapping, some of it's actually sewn together. Just pull out a sewing machine, just sew those together. They'll last forever now. They will not be coming apart on me. It's now a finished, it also looks finished. Get you an inexpensive sewing machine, sew it by hand. I mean, I could have sewn that by hand. It wouldn't have been a big deal. It's not a hard material to sew. So don't be afraid to branch out into other ways. Otherwise, you're going to be gluing it all together. Some of this material is not going to hold glue well, and you might be taking glue with you to every con because you're going to find out, why does this keep coming apart? Well, it's because you didn't sew it together like you should have. All right, let's get into the tech. That's about perfect timing. What time are we going to? We got half an hour?
Yeah, you got
Okay, fantastic. So that is the materials, but now let's talk about making this stuff as real as possible, getting into the tech of this. And I know the range of tech in this room is probably vast. Some of you could be developers that have been doing this for 30 years, and some of you could have never opened a compiler and know anything about that. So we're gonna try to high level this. I actually have another panel 2 days from now that is code and tech, and so if you want to go to that panel, I'll have that schedule up here at the end. That's going to go way deeper into the tech, although it's not a coding class, so hopefully you're not coming to learn C. The 1 hour C course. Learn everything you need to know about C programming. So high-tech cosplay. What are we doing with our high-tech? Again, everyone's going to be at a different place. Everyone wants to do something different. Someone might just want to add batteries and lights, and they're so proud of themselves. And I said that is the fantastic gateway project into electronics. If you learn that a circuit is built with a power source and a sink, and by making a closed connection, you get light, then you have gone further than most people will, right? So starting with the light project, starting to realize that you need this much voltage to power these LEDs, and depending on the amperage of the batteries, that they will last a certain amount of time. That is a wonderful place to start. That's a great starting project. You might even learn a thing or two about resistors when you blow up a couple of LEDs. So, when you look online and you realize, I can't take 12 volts into that LED, I wonder why it popped. You'll find forums that will explain it to you nicely. Or not so nice. And then you have basic electronics and ready-made kits. There are fantastic ways of learning to code, learning some basic electronics out there. In the past, I brought some of those with me. I didn't have time to get one for this one. But if you're learning ESP32, most of them are going to have the name Arduino on them. So if you look for beginning Arduino kits, they will come with the board. They will come with a number of sensors and LEDs and motors and all sorts of other things to get you started. And I recommend one of those kits because they come with sample code as well for you to start looking at how do I get started with electronics. I wanted something that lit up, but maybe blinked also. You know, I wanted a servo that lifted part of my armor up, and that will come with sample code. Those are a great way because you don't have to go and find which pieces I need to buy that work together. they've already provided pieces that work together. Advanced electronics, wired, wireless setups, command and control, monitoring. I'll cover some of that a bit more as I get to the end here. But just wanted to show kind of the progression here. There's just lights and batteries and things, and then you can get into the kits, which are going to help you learn. And then hopefully you get to the point where you feel comfortable branching out, starting to buy your own components. I've heard I could do this. Let me see what I can buy and blow up a couple of times and then finally figure it out. This is one of the ready-made kits I'm a huge fan of, particularly if you're into any sort of helmet cosplaying. The Crashworks team put together these boards for you. You throw a microcontroller on these boards. They have the connectors that you just have to throw in there, and they provide the code. And so all you have to do if you're building an Iron Man helmet in particular is one of these Crashworks kits. Again, it comes with the microcontroller, comes with the board, comes with the code on it, and it will suit you in a lot of situations, like I said, particularly if you're thinking of Iron Man. That'll take you to their eBay store, I believe. They gave me this 10% off code that is good for the rest of September. So they don't give out many of these, but they were cool with me having one. So for the rest of September, if you want to try out one of their kits, then there we go. And I will be giving away one before we're done here today. That's one of these basic circuits I was talking about. This is how you wire up a couple of LEDs, a couple of servos, a push button, all to a USB battery pack, and that is what one of these Crashworks boards do for you. They provide all of the wiring. All you have to do basically is potentially solder a couple of connectors to a couple of LEDs and stuff, but they try to make it as easy as possible without providing everything. All right, so how can I learn to code? How can I even learn to code before I buy my first board? Both Adafruit and SparkFun, I'm pointing these companies out because they're resellers. They sell you all the products you need, but they also provide free learning resources that you can get to using those two QR codes. I buy a lot from both companies. I don't have a preference really. They are both fantastic companies that provide a lot of sensors, boards, servos, whatever you need. They provide a lot of materials, and then after you buy it, you can click through on their website. They will give you, again, the code and walk you through how you get it set up and get it running. So I recommend both of these retailers, and they just do a fantastic job. What if you need help and you're tired of using forums and everything? Well, I'm a huge proponent of using online AI assistants to learn to code. I am a professional embedded software developer for my day job. I've been developing for over 20 years now, and I use this in my day job. And I use this to develop this Iron Man helmet. So there is no shame in doing this. It saves you a lot of time, and it is not always right. And I have to throw that out there because the number of times you will ask it to do something and it will be wrong and the code will not compile, it will happen. But for a lot of simple things, a lot of functions that have been written 100,000 times by every developer since the beginning of time, you can ask it to do that for you and it will do a fantastic job of handing you a sort function that you didn't want to have to remember to do again. You know, that kind of thing. If you want to know how to write an Arduino program that will blink an LED, you give it the board and you tell it where your things are connected, it will write that code for you. It does a pretty good job, of it. Again, not always going to be right. If it starts to fail when you compile it, then you probably are going to have to go look somewhere else, but it does a pretty good job. All right, let's get into my project a little bit, because this is about as far, I think, as anyone's going to take it in here. If you've got other plans that go beyond this, let me know, because I'd love to hear about them. So, I wanted to build the most technologically advanced Iron Man suit that anyone had ever worked on. And for me, that was starting with the user interface, or the HUD. Because once I had the HUD, I could build things that interface with it. I can build things that now will interact with this pretty easily, to be honest. This was the hard part. So I started with, how do I put a display in a helmet? How do I see the display in the helmet? And what is going to be able to run all of this? Because there is not a whole lot of hardware that can do this that you can carry around with you on your back or on your chest or on your hip, right? This has 2 cameras. It has 2 displays that act as a single display. It has the ability to record what I'm watching. It has the ability to stream it to YouTube while I'm wearing it. And it has the ability to do it all at 120 frames per second. So it takes a very special processor and computer to do it. And so I am going to tout NVIDIA here because I know of no other platform that can do it as of right now. Not something that's open source, easy to get your hands on, and is not government controlled in some way. So that's why the latest version of this is running a Jetson Orin NX, 16 gigs of RAM, and I use every single byte of it. So this, the beauty of NVIDIA's platform is it really is an NVIDIA video card, the same thing that you've got sitting in most of your computers at home that you play games on. It's got an NVIDIA Ampere GPU with 1024 cores on it. It has a 8-core ARM processor. Like I said, it's got 16 gigs of RAM. And the beauty of this is the 16 gigs of RAM is shared between the video processor, your GPU, and the CPU. So you don't have to, it's not 16 gig for this processor and 16 gig for this processor. No, they share it, which gives you a ton of flexibility. It means that if I maxed out my graphics card, I can offload it to the ARM processors. If I have too much on my ARM processors, I can now offset it to the GPU. It's given me a lot of flexibility, and again, I use every bit of it. And recently, with this last thing I'm going to share with you, I've even had to get into the idea of this will dynamically allow me to decide where my power goes, because this pulls a maximum of 25 watts while I'm wearing it. And if I go over 25 watts, it throttles, and that's not fun. So I've had to play with its built-in power settings where I decide what do I want my cores to run at, what do I want my processor to run at, how many cores of my processor do I want, and it gives you control of all of that. They have an online GUI that I can use to set all that up. Again, the tech here, I've got 2 cameras that you can see in the front of the helmet. These are 2, what are they running at? I think I'm doing 1080p on each of these cameras at this point. They can do higher, but I use frame rate, and I prefer frame rate to resolution as of right now. The 2 displays inside are 1440p each, so it's basically a 2K display across both eyes. And again, the balance here is you have to be able to carry it. You have to be able to wear it. I wear this on my chest in the arc reactor. It gets very warm. That's why there is foam on the back of it. It's great during the winter. All right. What did I build all of this on? So one of my keys here is this is not written in Python. All right. So if any of you are embedded developers, it's not written in Python. It is all written in C++. It is using libraries called GStreamer, SDL, and so it is all running native on the hardware. The GPU code is running native in the GPU. The CPU code is running native on the CPU. The initial version of this, you saw the video earlier. That version did have AI vision, meaning it was actually doing object tracking. I backed off of that temporarily because I want to do something slightly different with it, and I focused on other features, which we'll talk about here in a minute. But it actually does still have some AI vision capabilities. Depending on which large language model I'm using on the AI, it actually can do vision AI and tell me what I'm looking at and analyze the situation. It does have full speech recognition in the helmet, which will go and do 2 things. One, I've written my own command and control processing engine, which takes about 100 lines of just what's called JSON. It's just about 100 lines of text that says, I want this command, and I want it to do this, and I want this command, I want it to do this, and it turns it into like 500 different voice commands that I can turn it into. And that all happens automatically when I run the code, and it turns it into 500 different things that I might say that it should understand natively, and then it does those commands. So the key to this was command processing first. I wanted to respond to the commands. Those are more important than how you doing Friday. So if I ask it to turn off a display element, if I ask it to start recording or to start live streaming, those need to happen. If I say play AC/DC, it needs to play music because that needs to happen. All right, so this is version 1. Version 2 is sitting at home. I couldn't bring it, it's not ready yet. But I did learn some lessons from version 1. Fit is ultimately extremely important and very difficult to achieve in a helmet this size. You'll notice it is still oversized. I'm not embarrassed about that. So I'm okay with the fact that it's a little bit bigger than your standard Iron Man helmet. It has a heads-up display in it. So I'm okay with that. So keep in mind, basically, other people have commented online when they've seen this on Instagram or they've seen it on YouTube. They go, it's a little bit bigger, and I'm like, yeah, it's a VR helmet. It's an augmented reality helmet. We have something called optics that you can't stick something directly in front of your face and be able to see it. Put your hand in front of your eyes. You can't make out the details. You have to have optics. You have to put lenses in this helmet in order to be able to see the screen. And there's a distance there that has to exist. And so the second that someone develops a technology where I can put something immediately in front of my eyes or project it onto the back of my retinas, I would be happy to add it to my helmet. But as of right now, that's what I've got. Size, camera visibility. So the next version, you'll notice a lot of people like to pick up my cross-eyed Iron Man helmet. Again, it doesn't bother me. It has a HUD in it. So I leaned on that a little bit. So the cameras in here it was very important for me for the optics to be very high quality. You need to be able to walk around in this. You need to feel comfortable walking around in it. I walked around in this for an hour. Don't get sick. I can walk around and I'll bump into a whole lot. You lose a little peripheral vision because you're having to cut the cameras down to square cameras instead of wide-angled cameras. That's, again, just part of it. Again, I'm limited by what I can buy off the shelf, right? So, again, the optics in the next version, I am working on hiding them. Lower quality cameras, hopefully still high frame rate, lower resolution, less optics. The reason you see these is because they have nice lenses on them, which improve the optics. But, again, a lot of people care more about the aesthetics of the cosplay, and so there are options, but there are trade-offs to all of these options. Again, improved sensor accuracy. This one has some lower cost sensors in it. The new one has some new sensors in it. About out of time, so I'm going to go a little faster here. Hidden cameras, better power usage is not happening. Face mask automation, the next version, this one does not open, the next version does with the HUD in the faceplate. So the whole HUD and everything comes up in the next version of this face mask. The next one, this one are standard LCDs. The next version is a flexible OLED display that goes across the front of the mask. Again, trade-offs though. That has less frame rate. I can do 120 in these. The next one I'm down to 260. Again, trade-offs. Just 60 frames. Again, you have to choose, your goals and what you can buy off the shelf. Again, if you want to know where to find me, these are the 2 channels. If everyone will subscribe to the OASIS Project, that would help me get to my first 1,000 subscribers still. That's a budding new channel that I'm still working on. That's where, all my software and everything is going to be. Everything in this helmet is going to be open source. I've been saying that for about 2 years now. But it is going to be open source. I just keep working on it. I'm trying to release something that's relatively stable. Let's see, what do I have else up here? Where can you find me the rest of the weekend? At 4, I have a panel discussion on computer-aided design and 3D printed cosplay. I'm reading this off here. Let's see. Tomorrow, I have a single panel on the MSFM track, which is the military one. We're talking about cosplay. That's again a panel discussion. And then on Sunday, I'm going to kill myself with 2 more solo panels. One on cosplay electronics. Again, that's where I'm going to go more into embedded software development. So if you want to get real nerdy, geeky on the code, that's where we're going to talk about the platforms. And then we've got resin 3D printing, a beginner's guide. So if you want to build cool things like detailed parts, these are detailed resin 3D printed parts. All of the HUD elements in here are resin printed because they are highly detailed and require a lot better mechanical tolerance. And anyone in here building an Iron Man suit or an Iron Man helmet? One here, you got there.
I tried about 15 years ago. So I'm interested, but never got there. Got the helmet. I've got the eyes will light up, no servos.
How far along are you?
I've actually got it's a display for mine. I use something called video glasses, which were a early 2000s product, I believe. And I'm using a drone camera.
Okay.
For that, and it goes up to the faceplate because they're like nothing. They're VGA. So the resolution is thin, but it works.
Fantastic. Is yours already motorized?
Yes.
Okay.
I didn't break it.
Where are you on yours?
I have all the pieces printed. I'm doing a Mark 43. I'm working on sanding and primer paint right now. That's also doing paints. I came to your panel.
This is yours. Oh, I'm sorry. It's his. There you go. I hope that helps you with the next step.
Oh, this is going to be interesting for the helmet. Thank you so much.
No problem. Go send them a message on one of their socials and thank them. They provided them. All right. So, Q&A time. And one last thing. The last bit of memory on this is being used. The AI assistant is now running locally. This is no longer using OpenAI. She's running on here locally. She's part of the boot up process. So I no longer have to go to the cloud. She no longer requires an internet connection to use. Lots of questions. We're going to start on this other room and work our way back.
So, I'm sorry, I think the first one should be quick. Does ABS cause fumes issues after it's been printed, like if you're wearing it as a helmet?
Should not. Most of these, once they're printed, it's the heating that causes the off gases. Do you have a second question?
Yeah, what about magnets for attaching? You
Yeah.
mentioned it, but
You're right. I did not add that to my presentation. I do use neodymium magnets for a lot of my connections. A lot of people will find that they do come off if you don't use enough of them. So I would say magnets are fantastic, but if you have a run or if you have a stretch, to put them often, because otherwise they will come off. I use them on here and they generally have held, but I've also recently added a piece of elastic to the back, just in case.
do you sew them in or do you like print them in?
Actually, I'll use a 2-part epoxy because sometimes CA glue, super glue will work, but it's very brittle, and that's why it doesn't hold. It's because it's brittle, it will crack, and then the piece falls off. So 2-part epoxy, get a 2-minute or a 5-minute epoxy that you can work with. And then what I like to do is I will actually put that epoxy over it a bit. You don't want it too much. If it's the thicker you put it over it, the less magnetism will be between the parts. But then you can sand it down, paint over it, you don't even see the magnetism. Yeah.
You talked about going online to effectively get designs for helmets, etc. Are you having to put in specific unique requests when you're commissioning those pieces, to account for all the LEDs, etc. inside?
No, I work with the designs I have,
Okay.
and sometimes I will buy 5 of them.
Okay.
So it can be very expensive if you have very particular requests or very specific ones. Now you can contact them. Some of these people are very easy to work with and will work with you. Some of them not so much. Some of them are one and done, and I'm selling this and this is what you get. It depends, and there's a lot of 3D modelers these days. I can't recommend one because I haven't worked with most of them. But there's a lot of people online wanting to take their money these days to model something for you. You can give them a shot.
And Blender is easy to work.
Yes.
Yeah, actually a helpful comment. You're talking about nylon webbing. From my area of expertise, if you get automotive seat belts, if you need something that width and size, the passenger and rear seat belts never get worn out. They're cheap and free at junkyards. They cut them out of cars and use them to strap engine and transmissions in a pickup when they're delivering them somewhere and stuff. And some of the high-end cars have really interesting patterns. You might have a black belt with a red fringe on the edge, a weird pattern woven into it.
That's cool.
You can buy it new as well too. That's something I've learned.
Cool, thank you. Yes.
Can you speak to the thermal insulation properties of the different foams? Because I'm worried about sweating really hard.
Well, again, that's why I went with another reason I went with the neoprene, because a lot of this close cell stuff here is not breathable. It will not breathe at all. Most of the open cell foams like this are breathable. That's why they're open cell. That's because they air passes through them. But again, think about it. I mean, these are wetsuits, so they're pretty breathable. People are doing well in wetsuits for a long time, so I can't speak particularly like how much will you sweat in this material than this material, but I think that's the basics.
Could I say? Sorry.
Yeah.
I like foam a lot.
Sure.
EVA foam, whatever color, it absorbs heat. You will sweat and you will take your thing off, and all of that sweat's going to drop out. The nice thing about the neoprene, it comes in a lot of the same millimeter thicknesses, but it is a breathable athletic fabric. So if you're going to use 3 millimeter foam inside of 3D print, don't.
Yeah. No. And the other thing is, when you're at your material store, be sure to go back to the back section where they have their you might know the name of that section, where they have like their household fabrics, the things that they use for automotive or the upholstery section. Exactly. That's where you're finding the thicker stuff. They'll have their thinnest stuff with the regular fabrics, but if you want stuff this thick or thicker, you're going to have to go back to that area, to the upholstery section.
Also put neoprene under your foam if you use it.
Okay.
Yeah, you can use both, absolutely. Layering your fabric.
Even just like 2 or 3 layers, it gives you that breathing, the EVA foam.
Right. Yeah.
All right, so I've got 2 costumes finished, Captain Enoch and Amanda Warren. I've used the same mic so I can actually talk to people when I've got a costume that goes dead. Should it be Bluetooth? Is there a recommendation for like a speaker for those types of costumes?
Bluetooth gives you a lot of options because you can choose whichever mic you want and then choose whichever Bluetooth speaker to pair it with, as long as they support the same protocols. Make sure you check that if it's a V3 or a V4 or whatever it is. Make sure they support one another. I like the idea of Bluetooth, plus you can choose a lot of Bluetooth. Where are you keeping, like, where's the battery for this
Okay,
unit?
so the thing I have is actually made for a speaker like you in a small room, and you just put it on your belt,
Okay.
and then there's a wire that runs up into my ear, and I just when I take the helmet off.
Does it run off of double A's or something?
No, just plug it in and it charges up. The
Okay.
problem is overnight, especially bending over, I had to knob it wrong place, and I was bend over.
Well, I mean, one thing I think of when I just add a USB battery pack to it.
Yeah, right.
And then it's charging the whole time, and now you've got a battery backup already built in, and then you can use what you have. Yeah. A lot of Ironman, half the suit runs off of a USB pad because they're 5 volts. Everything runs off of USB these days, and so you can run those off of USB.
Favorite 3D printer, large format.
So if you check out my YouTube channel, it's Ender 5 Plus, which is. It's getting a little long in the tooth, and it's hard to recommend it at this point. So I have 2 of those, and they're fantastic machines, but they need a lot of work to kind of bring them up. You're going to be doing a lot of mods. My favorite printer, probably in my garage, besides the Ender 5 Pluses, is the V400, an FL Sun V400. It's not as big. It's a Delta printer, which means that the print head is round. Instead of square. So it's not quite as much real estate as the Ender 5 Plus, but it's super fast, easy to maintain. I can't say enough good things about the V400. I probably use it more than my Ender 5 because of the speed. And I like it better than the Bamboo Labs printers because it's easy to work on.
Yeah, I love my PS1. I love that.
Yeah. And so that's why I actually don't own a Bamboo Labs printer today, mainly because of just the fact that they're relatively closed systems. They're harder to work on if something breaks, and I really like to be able, if the mister goes out, it's nice to be able to work on it.
Thank you.
Thank you. All right, I think that's it. If you have any other questions, I'm sorry I didn't get to everyone. Like I said, there was a lot to cover. Please come up. I've got just a few minutes while I'm packing up. You can ask me questions directly. Please come see the stuff on the tables. The only thing I ask is that you leave them here. Thank you.